Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring exponential growth and decay. The exponential growth and decay formulas are very similar to each other. Exponential growth is y equals a times the quantity 1 plus r raised to the x power, where a represents your initial value or starting amount, r is your rate expressed as a decimal, and x is the time. Now, when you're dealing with exponential growth problems, they won't come right out and tell you it's exponential growth. So you're looking for words like some increases. A quantity is increase. So, let's write that as increasing. A quantity is increasing. Sometimes they'll say the population is growing at a certain rate. Another word that you might be unfamiliar with is the word appreciate. Appreciate has two meanings. We can say appreciate to someone if we're grateful for something, but when we're talking about a quantity or a value that appreciates, like you might say that the Johnson family bought a house and it appreciated over the next 20 years. That means it grew in value. So the word appreciate, when you're talking about money, means to grow in value. Okay? Now, exponential decay is almost exactly the same, except for inside the parentheses, instead of a plus, you're going to see a minus. So we have y equals a times the quantity 1 minus r raised to the x power. Your a is still your initial value. Your r is still your rate. And your x is still your time. But the words you see that denote exponential decay functions might be something like the value of the car was decreasing, or you might see the word, decay, like a radioactive substance decayed at a rate of 5% per year or something like that. You can also see the word depreciate. For instance, when you buy a car, cars depreciate in value over time. So when you buy a car for $20,000, in 2 years it might be only worth $15,000. In other words, it depreciated. Okay. Now let's look at an example of this. In example 1, it says biologists estimated that a population of 270 whales in the North Atlantic Ocean increased by 2.9% each year. Write a function to model the situation, and then determine the number of whales after 5 years. So is this growth or decay? Well, they gave us a clue word right here. They said increase. So we know this is growth, and the formula we'll use is y equals a times the quantity 1 plus r to the x power. So our initial value in this problem was 270. So that's our A. The rate, now you have to be careful here because you can't write it as a percentage. We want to take 2.9% and convert that into its decimal form. So move your decimal places 2 to the left and fill in your missing 0. So 0.029. So that's our R value. Remember, your rate is a percentage that's expressed in decimal form. All right, so your function will take y equals our initial value, 270, times the quantity, 1 plus the rate, to the x power. So our simplified function would be y equals 270, combine what's in the parentheses to get 1.029 to the x power. And the last thing they want us to do is use this formula to calculate the population of whales after 5 years. So x will equal 5, which means we will plug in our calculator y equals 270 times the quantity 1.029 to the 5 power. So you're going to need a calculator. I'm going to use Desmos, but you could use any type of calculator you want for this. So 270 parenthesis 1.029 close parenthesis raised to the 5 power. Now, in Wales, we want to express our answer as a whole number. So this would be approximately 311 whales. All right, example 2. There are 1,024 players in a tennis tournament. In each round, half the players are eliminated. Write a function to model the situation and then determine the number of players left in the tournament after 3 rounds. So the first thing we want to determine, is this a growth or decay situation? Well, they kind of gave us a hint right here, saying that half the players are eliminated, which means the number of players is decreasing each round. So this would be decay, and we would use the formula y equals a times the quantity 1 minus r to the x power. Now, our initial value in this problem was 1,024, and the rate. Now, what they told us is half the players were eliminated, but we have to express our r as a decimal. So 1/2 as a decimal would be 0.5. All right, so our function would be y equals 1,024 times the quantity 1 minus 0.5 to the x power. So the simplified version of this would be y equals 1,024. 1 minus 0.5 is simply 0.5 to the x power. So if I want to know how many players were left after 3 rounds, I would put in my calculator 1,024 parenthesis 0.5 raised to the 3rd round. So there would be 128 players. All right, example 3. The market value of a car depreciates at a rate of 6% per year. If a new car was $28,000, write a function model to model the situation and then use the function to determine the market value of the car after 10 years. So is this growth or decay? Well, the clue word came right here, depreciate. That means it's going to go down in value. So our formula would be A equals 1 minus R to the X power. Now, the initial value of the car, what you bought it for, was $28,000. Now, the rate, remember we have to take our percentage and express this as a decimal, so 0.06. So our function y equals 28,000 times 1 minus 0.06 to the x power. So our simplified function would be y equals 28,000 and then 1 minus 0.06 would give us 0.94 to the x power. So to find the value of the car after 10 years, we would take 28,000 times 0.94, all raised to the 10 power. So I'm going to round this to the nearest dollar and say that it's worth approximately $15,081. And I should probably put a dollar symbol there. All right, example 4. At the beginning of the winter season, Mr. Henry's firewood rack held 4,000 pounds of firewood. The weight of firewood decreases by 7.5% each week. Write a function to model the situation and then determine the number of pounds of firewood left in the rack at the end of 6 weeks. Pause the video and try this problem on your own. All right, welcome back. Let's see how you did. Hopefully you said this was a decay situation, and the formula is y equals a times 1 minus r to the x power. Your initial value was 4,000. Your rate was 0.075. Your function rule, 4,000 times the quantity 1 minus 0.075 to the x power. The simplified rule being 4,000 times, let's see, what was that? 1 minus 0.075 would be 0.925 to the x power. So to find the value, to find the amount of firewood after 6 weeks, we would take 4,000 times 0.925 raised to the 6th power, and that would give us approximately 2,506 pounds of firewood. All right, example 5. Determine whether each function represents a growth or decay, and then identify the rate of growth or decay expressed as a percentage. All right, so to determine if it's growth or decay, you look at your base. If it's bigger than 1, it's a growth, and if it's smaller than 1, it's a decay. So this would be a growth. And to find the percentage growth, you take your formula, which was 1 plus r, because it was growth, is equal to whatever is in the parenthesis, and then you solve for r. So I would subtract 1 from both sides. So the rate would be 0.02, and then you express that as a percentage. So move your decimal 2 places. This would be 2% growth. All right. Problem B. This is growth again. And so our formula for growth is 1 plus r equals whatever's in the parenthesis. Subtract 1 from both sides to get the rate of 0.3, and then convert that to a percentage. 30% growth. All right, now when it's decay, like our next problem, this is decay, we don't want to use the formula 1 plus r, we use the formula 1 minus r. So 1 minus r equals 0.94. Subtract 1 to get negative r equals 0.94 minus 1 would give us negative 0.06, and then divide both sides by negative 1 to get rate equals 0.06, which would be 6% decrease, a 6% decrease. All right, problem D. This is also decay. So we're going to use the formula 1 minus r equals 0.6. Subtract 1 from both sides to get negative r equals, and then just take your 0.6, subtract the 1, and that gives us negative 0.4. Divide both sides by negative 1 to get positive r equals positive 0.4, and then convert that to a percentage. So move your decimal 2 places to get our rate is 40% rate of decrease, 40% decrease. All right, pause the video and try problem E on your own. All right, welcome back. This was growth. So we're going to use 1 plus r equals 1.025. Subtract 1 from both sides to get rate equals 0.025. Move your decimal 2 places to get 2.5%. All right. This next problem, our base is bigger than 1, so this is growth. So 1 plus r equals 2. Subtract 1. So rate equals 1. Now we want to write 1 as a percentage, so I move my decimal 2 places. So if this is understood to be 1.00, if I move my decimal 2 places, this would be 100%. 8% growth. And that concludes today's lesson on exponential growth and decay.